Welcome to this introduction to complex numbers. This is a topic that has applications in electrical engineering for representing AC signals, in fluid mechanics, and more. Whilst this topic initially seems quite abstract, as it deals with numbers that are called imaginary, it is more intuitive to think of them as a means of obtaining more useful information. A complex number is represented by either an I or a J. J is used in electrical and electronic engineering, as I is usually used to denote current. The main point is that this notation is used to represent the square root of -1. Often, we write in the form z equals a plus bi. The notation used at the bottom of the slide states that a and b are in the set of real numbers. This is the number system we are used to using, without realizing it is a part of many number spaces. Whereas z is in the set of complex numbers due to the inclusion of the complex number I. It is difficult to understand how this can be used, but we start by understanding what this means and how we manipulate a complex number. This will allow us to appreciate how complex numbers can be used to obtain useful results. To graphically represent a complex number, an Argan diagram is used. Noting that the vertical axis has been labeled as the imaginary axis, and the horizontal axis has been labeled as the real axis. Algebra works in much the same way as when we deal with variables like x, y, z, and so on. We collect like terms when adding and multiplying as shown. The only difference is that we remind ourselves that I is the square root of -1, so I squared is equal to -1. The modulus and argument can be obtained using familiar maths. If we treat the complex number as a vector, we can understand how any complex number can go partially in the direction of the imaginary axis and partially in the direction of the real axis. Then, using Pythagoras' theorem and trigonometry, we can obtain the modulus and argument, as shown here. We conclude with some final remarks. Complex numbers are used as a means of finding useful and real results in mathematical workings. This will become apparent in later videos. Like and subscribe for more.